Hello guys, this is Matthew. I thought I'd like Clive style video, just because that was fun and also wasn't very hard. So I thought, why not look at some cheap night lights. I actually wanted to see if some night lights that you get in places like Walmart, which are, you know, admittedly still some pretty cheap shit, are going to be the same as the ultra cheap night lights you see from places like eBay. So yeah, I thought that could be interesting. Here is here is the little night light. Kind of looks like it might have a I don't know, like a straw hat LED or something. Can't really see. And then has an LDR on there. Nice solid plastic dome here. Doesn't seem very breakable, which is great. It definitely feels better quality than some of the others, but what I'm really interested in is just what are they doing inside? You know, is it the same kind of transistor shunting the mains voltage type of circuit? It did seem like it had some smoothing to it, but you know, I'm not sure if it's just like a resistive dropper or what. So let's pop it open. Oh, and sorry in advance for the shaky camera work. You know, I've got one of these Gorilla Pods that are really awesome because you can stick them everywhere, but they really suck for video because they just aren't. Oh, this isn't gonna come apart without being in pieces. They just are well, they're made of plastic and rubber, you know. There's not a whole lot to say else about about it than that. I mean, it's definitely do I got it? Oof. Wow, didn't even lose a finger. Oh, it's a little surface mount chip. Huh. Is that, one second, is that a spotted damage? Let me take a look. No. Just a little bit of, will that focus? A little too close. Just a little bit of crusty, crappy solder. Looks like it's just glued on here. Something like that. Yep. Just like some super glue. Let's bring a little bit more light in here. Bring it down a bit closer. There we go. All right. Let's grab the screwdrivers. It's more difficult to be coordinated along around a camera than I thought it was going to be. That's all right. I'm just using my cell phone for this. Figure it makes for a pretty good camera. All right. Looks like it's got a little bit more going on for it than, well, maybe, there we go. Oh, what little piece of something fell off? I probably just, oh no, I think I just took a little bit of that the clear plastic off. Have the pins right on it. All right. So, here's the LDR. Looks like, so we've got a resistor in here. What's that? So here, let's zoom in. So an S9014. So that's just a really common NPN transistor, I'm pretty sure. And looks like we've got, oh, come on, stop focusing it in and out like a piece of crap. Looks like we've got a capacitive dropper from what I can see. But we've got a lot of different styles of diodes on here. What, 1, 2, 3, 4. So 4. Oh. That's interesting. It's like they're using two of the 1N007s and then, sorry, 1N4007, and then some more of these, what are they, the 4148 diodes instead of, that's weird. Why would they use two different styles of diodes? Huh. Anyways. Hey, look at that. That says D5. Or D3, like it's supposed to be a diode. Did they all say that? No? Did they stick a resistor in instead of a diode? I haven't even plugged this one in. I don't even know if it works. Alright, so yeah, it looks like we've got coming through a 470 ohm carbon film resistor there. It comes over to the capacitor. So yeah, it's a capacitor dropper. And it's got a little lead down resistor there. So that's what? 5-1. Does it have a third band? One second. Yeah, yellow. So 5-1 in yellow, so 51K? Alright, that seems kind of low to me, but it is what it is. It's a 250 volt polypropylene capacitor because we're in the United States. You know, as it is a as our voltage is only 122 volts, I think peak rectified main voltage is 170. So it's well within the rating of the capacitor. So yeah, so it comes across and then it goes from there to there. So that's the positive rail. So yeah, so this part's the positive rail here, and if that little, it's out of the negative. Right, yes, because we've got the LED coming in here. I wonder if this is just a single LED or if it's if there's multiple chips on the surface mount package here. We'll see. That comes across to this resistor. That's supposed to be that maybe could be a diode. Nah, just for current limiting. It's like they just did the silk screen wrong. So that's a what, 101. So wait, is that blue? Sorry, these are teeny little resistors. No, one black. Okay, so yeah, so it's just 100 ohm. So yeah, just for current limiting for the LED. Then it comes across to right, and the yeah, it looks like the LED's shunting Yeah, it looks like the LED. I mean, the transistor's just shunting it here again, because you see we've got the LDR here going to the base of the transistor. I think pretty sure this will go collector base emitter. Yeah, and then this just goes back as a back. Right. Okay. Yeah. Do you want? I'll just jot this down, the schematics for it, and then come right back. So I jotted down the schematic here, but I just wanted to first. My curiosity got the best of me, so I opened up the other one, because I wanted to see if this resistor here that's marked as a diode, it has a diode in it, and sure enough, it has a diode in it, but it doesn't make any sense. It's in terms of how the schematics are, but something else is fun about this one. So you'll notice that looking from this side, that something's missing here. One of the diodes. If you turn it around, they've just got it bodged across the back here. Also, I noticed this here. You'll notice the pin is all weeble wobbly, and yeah, I didn't do that. That was just already, the track is already coming up, which is why I really don't like it when they do this. But yeah, so pretty much everything else is the same, but yeah, it does have a diode there, and I'll show you where this diode would normally be, or where this diode would be inside the schematic. But yeah, there's no reason to really worry too much about it. But pretty much everything else is the same. Looks like it's a different manufacturer for the capacitor, and but the same value. This one seems to be nicer. This one seems a little like the finish is different, and yeah, well, doesn't really matter. Right, so let's look at the schematic. And this is going to be a little weird. Let me set my tripod up on the page because I don't really have a good spot. So I divided this into two sections. The left side is the power section, and then the right side is the circuitry that'll actually do the nightlight portion here. 1 second here. So first off, let's look at the power section here. And this is a bit fidgety of the thing. Okay, so to start off with, we come through 470 ohm resistor. That's this resistor here, and then we go over to the capacitor. The capacitor is 680 nanofarad. I'm really horrible with codes here, but the 564 there, that is the 580 nanofarad like code. But you can just look that up online if you were looking at capacitor codes, so not that big of a deal. Across that we have a 51K discharge resistor. That'll just keep it so that this capacitor discharges itself once it becomes unplugged. Otherwise, it would hold on to a charge and could give you a zap at 120 volts. Then we go over to the bridge rectifier. Most of the time, you'll see people, they'll do the triangle thing, or the diamond thing. Let me focus on that a bit better and bring up the light. There we go. I don't really do it that way, just because I really suck at drawing a triangle on an angle. Also, this just makes more sense to me. Like all it is it's the triangle. I mean, it's the diamond shape, except it's splayed apart and then drawn straight on the side. So I like doing it that way. And you see, this is the positive side. This creates the positive rail. This creates the negative rail for the unsmoothed DC. And strangely, they have, for the where the positive rail is created, they have the 1N4007 diodes, and then where the negative rail is, they have the 1N4148. At least I think that's the code. The diode, I just honestly I can't remember it for sure. What the smaller ones are, but I'm pretty sure that's right. And then I'll just create this unsmooth DC. This right here that says ESR, that means equivalent series resistance. That's referring to this capacitor. That is the resistance of that capacitor if you were to replace this capacitor with a resistor, it would be a 3.9K resistor as far as what it would be, what its resistance is. And I'll show you how to actually calculate that here in a second, but it's a little mathy, so I'll save that to the end. Now looking over at the actual active circuitry here. Let's adjust that a little bit. Sorry about that. Okay, so we have the LED here. It does look like a single LED. And then it goes through a 100 ohm current limiting resistor, just for the heck of it, I guess. It does have some resistance over here and everything. Well, it doesn't matter. Current limiting resistor there, and then that's smooth with 100 microfarad capacitor. And it just keeps going out of focus, guys. Sorry, 1 second. That's a little bit better. That's a 16 volt capacitor. So that's this guy here. And you see on the back of the board here, this outer rail is essentially the negative rail. And come on, focus. And then this rail here with this crappy diode tacked across it, that's the positive rail. And that basically just makes the LED light up and gives it smoothing. To turn off the light, all that's happening is that we have a light detecting resistor here that passes voltage through when it is able to. And then it creates a resistive divider here. You can adjust the sensitivity of this if you were to increase or decrease the value of this resistor. But anyways, we've got a little resistive divider here between the light detecting resistor and the just standard 10K resistor. And then that goes to the base of the NPN transistor. So when it detects light, it's putting voltage to the base of this resistor, or this transistor, I mean, and then just shunting across the positive to negative rail. And since it is now the path of least resistance, the LED will turn off. And that's a really common way of doing night lights. But with that being considered, it basically means that you're drawing much more amperage when the light is off than you are when the light is on. I don't have, well, maybe I will demonstrate that. Maybe I'll actually measure the amperage going into it when it's off versus when it's on. Yeah, I will do that and be right back. So I've got everything kind of spliced in line with some multimeters. So this big old dangerous mess of looking of wires here, it looks dangerous because it pretty much is. So don't do this unless you are used to working with higher voltages. So all I've done here is I've spliced in line with some power coming from the wall with this wire with the switch on it, and that's basically just going through this top multimeter here, and that multimeter will measure the milliamps in AC for the 122 volts AC coming out of the wall, and then this down here will measure the milliamps running through the chip that This will do the milliamps running through the chip in DC, and that's for a voltage of 2.65 volts. I measured the voltage a second ago. But from there we can work out how inefficient the entire circuit is. All right, let's do this. So turning this on, making sure there's no stray wires or anything. All right, so right now the LED's not lighting. You can see right down there with that red wire going underneath the vise. That's the LED, and it's kind of pointing right at us. So it's going to swamp out the camera probably. But without that, right now there's no amperage going to it because it's turned off, because you can still sense light here, and it's using 25 milliamps of AC current coming from the 122 volts from the wall. So if we do the math on that for a second here, that will be 122 times 0.0. I said 26, 25, right? Yeah, okay, 25, and that equals about 3 watts. So right now it's taking about 3 watts of power. If you put that into perspective, that's about the same amount of power that you'd use to power one of those like Cobb LEDs, you know, one of the smaller Cobb LEDs, or not Cobb LEDs, I'm sorry, the Star LEDs. Anyways, so now if we block out the light, it's gonna swamp out the camera a bit here. Then we've got about 10 or 11 the more light I block out, the more it takes. But I think when I measured this a second ago, the highest I saw it go was 15 milliamps, or between 10 and 15 milliamps. So if we just do 15 milliamps, and then look at the actual output of this LED, we've got 2.68. That was the voltage I measured across the LED before. And then that's times 0.015. Then we work out a total wattage of 0.04 of a watt. So really nothing at all. I mean, absolutely insane. So that shows you how much of the actual circuit is being used for just the support circuitry, you know, and dissipating the energy. If you actually go like this and then do it, you can see from this top one that it really doesn't change when it's off or when it's on. It's pretty much the same. And that's because it's just using as much power as it'll put out. So with that being said, let me turn this off. You can always do what Clive did before. He just cut out the transistor, and then it just makes the light stay on all the time. And you get a little bit extra illumination during the day, and then you're not just wasting the energy with no benefit at all. And I think I'll do that now, but I think that I'll make this the end of the video. So hope that you guys found it useful. I was going to show you how to calculate out the equivalent series resistance of the capacitor, but I'll do that in another video. Right now it's just if we do it right now, it's just gonna make this video even way longer than it already is. So anyways, I hope you guys found this video informative and useful, and yeah, this was fun. You'll probably see a lot more videos like this from me, just because the other videos I was trying to make just took way too long. You know, when you're really trying to make a video, it just takes for fucking ever. It's unbelievable. And I don't even have enough time to do the stuff in my life that I need to do, let alone all of a bunch of like videos on electronics, basic type stuff, and all of that, which I'd really love to do. I just don't have the time for it. But I hope you guys like this video, and hopefully you'll see more of them here. All right, bye.